Salam, peace be upon you. My name is Muhammad Laik Sidipi, the father of Holophase. Part 30, Probability, Energy, and Entropy as Derived Readouts of Phi Pattern Dynamics. We have reached a strange and beautiful moment in the story. The moment where three famous words stop being mysterious. For a long time, ordinary language has treated them like invisible substances. Probability sounds like a kind of floating chance. Energy sounds like a fuel that sloshes from place to place. Entropy sounds like a dark spirit of disorder that pushes everything downhill. But after everything we have already built, we cannot keep speaking that way. If pattern is primary, if only relations are public, if every claim must carry its window, scope, and provenance, then these three words must also be disciplined. They must become readable, auditable, and non-mythic. They must become what they truly are at this layer: structured summaries of pattern change under finite access. So we make a clear turn. Probability is not chance stuff. Probability is a measure we assign over lawful branches when a state has more than one certified continuation and our excess cannot resolve which branch will be realized. Energy is not a substance that flows. Energy is a ledger, a conserved tally we can keep across a declared family of lawful transformations given declared boundaries and an agreed update rule. Entropy is not mystical disorder. Entropy is multiplicity under coarse description, a count of how many fine-grained pattern states remain compatible with the coarser story given limits of resolution, declared windows, and declared coarse graining. These are not demotions. These are clarifications. Each word keeps its power, but the power becomes honest. The first parable, the weather board. Consider the simplest everyday scene, a weather forecast board. It says 60% chance of rain. Where is that 60% located? It is not a fluid in the clouds. It is not a molecule. It is not hiding behind the horizon. That number is a summary of branching under finite access. Many future atmospheric states are adjacent to today's state, because the lawful dynamics of air, water, and heat allow several continuations. Our sensors cannot capture every detail of the current state. Our models simplify. Our computation is finite. So we take a disciplined step. We represent our uncertainty as a measure over the lawful branches. The important thing is not the number itself. The important thing is what must be declared for that number to be public. What is the window? Which data sources and which measurements are allowed in? What is the branch structure? What outcomes count as distinct branches? Rain, no rain, light rain, heavy rain? What assignment rule is used? Frequency from ensembles, symmetry, Bayesian updating, historical calibration? What are the predictability limits? How far can this procedure hold before it becomes meaningless? What is the provenance? Which model version, which parameter settings, which selection filters? If these are not declared, 60% becomes a spell. If they are declared, 60% becomes a lawful readout. That is our first rule of Part 30. Probability is a measure over lawful branches under finite access, and it lives inside the claim structure, not in the sky. 2. Probability as disciplined branching measure. We already installed branching in adjacency. A single pattern state may have multiple lawful next states. That is not chaos, it is structure. The universe, at many scales, offers forks. Now probability arrives as the disciplined way to speak about forks when the fork choice cannot be resolved. A simple fork, a coin flip. At the human scale, the flip has two obvious branches, heads and tails. The key point is that both branches are lawful continuations of the same starting state. There is no violation of law when the coin lands heads, and no violation when the coin lands tails. The uncertainty is not lawlessness. The uncertainty is finite access. We do not know the exact micro details, the release angle, air currents, tiny asymmetries, elasticity of the surface. So we treat the future as branching, and we assign a measure, often 1/2 and 1/2, because the setup is symmetric and repeated trials calibrate the assignment. If we secretly load the coin, the branch measure changes. If we instrument the flip perfectly and compute the trajectory, the uncertainty shrinks. If we define branches differently, the probabilities change. If we change the window, the probabilities change. So probability depends on the branch set, which continuations are being distinguished, the window, what information is available, the uncertainty budget, what cannot be resolved within the window, the assignment rule, symmetry, frequency, model-based or belief-based, the calibration, how the rule is checked against repeated outcomes when repetition is meaningful. This is why random cannot be used as a lazy explanation. A stochastic claim must say, at least, which branches exist, which measure is used, and why. Otherwise, the word random is just a curtain. Now, the deepest example, quantum branching. A beam splitter offers two paths for a particle. Standard quantum practice assigns probabilities by the Born rule. But even here, at our layer, the discipline remains the same. Declare the branch structure, declare the assignment rule, declare the access regime and predictability limits, and declare the provenance of the experimental setup. Probability remains a readout, a structured summary of lawful branching under a declared measurement window. Probability, then, is not a primitive dice inside reality. It is the lawful way to speak when branching is real and resolution is limited. 3. The second parable, the bank ledger. Now we walk to the second famous word, energy. Ordinary talk treats energy like a fuel, like water in pipes. Energy flows from the battery to the motor. Energy gets used up. Energy is stored. These phrases are helpful, but they are also dangerous. They invite substance smuggling. They make energy sound like an ontic fluid. So we use the simplest analogy, a bank ledger. A bank account has a balance. The balance changes when deposits or withdrawals occur. The balance is not a substance in the account. It is a number that tracks a history of updates according to rules. If a payment is made, nothing flows from one account as a physical fluid. A ledger entry changes in two places. The rules define which entries count, how they sum, and which operations preserve the totals. Energy at this layer is exactly this kind of thing, a tally that stays stable across a declared family of lawful transformations. When we say energy is conserved, we are not describing an invisible substance that must remain. We are describing a bookkeeping invariance. Under declared transformations, the ledger total does not change. That is why energy depends on what counts as an update, which transformations are included in the family, what ledger is defined, which quantities are being tallied and by which formula, what boundaries exist. Is the system closed or can ledger entries cross the boundary? What readout level is used? Is the ledger tracking only mechanical changes or also thermal, chemical, electromagnetic, and so on? This explains a familiar lesson from school. Mechanical energy seems conserved when friction is negligible and seems not conserved when friction is strong. The deeper truth is that the ledger changed. We were tracking only part of the update story. When friction hits the air and the surface, mechanical energy is not lost into nothing. It is moved into a different set of ledger terms. The accounting must expand. So energy is not a substance that disappears. It is a conservation-friendly way of keeping score across lawful change. 4. Energy across scales, from children on swings to stars. To make this feel real, we walk across scales. At the playground, a child on a swing rises and falls. At the top, speed is small and height is large. At the bottom, height is small and speed is large. The ledger says, potential term plus kinetic term stays roughly constant if air resistance is small. The swing does not contain energy as a liquid. The ledger is describing a stable relation among measurable features under a declared transformation family, the family of swing motion under gravity in that boundary setup. At the scale of machines, a car engine converts chemical patterns in fuel into motion patterns in pistons, plus heat patterns in exhaust. The energy ledger is our way of tracking that conversions are not magical. Something is always being updated, and the total in the correct ledger stays stable. At the scale of ecosystems, energy flow language appears again. Sunlight drives photosynthesis, which drives food webs. Here too, the ledger idea clarifies. What is being tracked is not an ontic fluid, but a chain of transformations whose totals can be budgeted. Calories become a unit of accounting. If the accounting is correct, the story is not mystical. At the scale of stars, fusion changes pattern states of nuclei, releasing radiation. The energy ledger captures the stable bookkeeping relation that allows prediction and coherence. But again, the ledger depends on declared scope and boundaries. Which radiation escapes, which remains trapped, which counts as part of the system. So energy is a public discipline, an accounting framework that prevents ex nihilo talk and prevents disappearance talk. It is a guardrail against myth. 5. The third parable, the messy room and the card deck. Now we reach entropy, the most misunderstood word. Popular talk says entropy is disorder, as if disorder were a substance that accumulates. Or it says entropy causes time to flow, as if entropy were a hidden engine of history. Our framework cannot allow that. Entropy is not the spirit of disorder. Entropy is a count. It is a statement about multiplicity. How many fine-grained states are compatible with a coarse description? The everyday parable is a room. A room can be described at high resolution, the exact position of every sock, book, cup, and dust particle. Or it can be described at low resolution. The room is clean, or the room is messy. The messy description is compatible with a huge number of micro-arrangements. The clean description is compatible with far fewer arrangements, because clean demands a specific structure: books aligned, clothes folded, objects put away. That is why mess returns easily and clean must be maintained with work. Not because disorder is a force, but because there are vastly more messy microstates than clean microstates. Entropy is the log count or any agreed monotone summary of that multiplicity. The concept is the same whether we use a logarithm or not. Entropy is about how many detailed realities hide behind one coarse sentence. The second parable is a deck of cards. Sorted deck describes very few microorders. Shuffled deck describes many more. If the deck is repeatedly mixed, the set of possible detail orders expands, and the coarse description, random looking, becomes compatible with almost all microstates. Entropy increases because the multiplicity behind our core story increases. Again, Entropy depends on coarse graining. Change the criterion of sorted and the multiplicity changes. Change the measurement window and the entropy changes. So entropy depends on the coarse graining rule, how fine states are grouped into macro stories, the resolution limit, which details are invisible within the window, the state space, which microstates are even allowed by the constraints, the boundary and update family, which transformations are being considered. Entropy is a readout of access and description, not a mystical property of disorder stuff. 6. Entropy across scales, gas, cities, and language. We now walk across scales again. At the scale of a gas in a box, microstates are the positions and velocities of molecules. Our window cannot see them individually. We measure pressure and temperature. That is the macrostate. Entropy counts how many molecular microstates match those macro measurements. If the gas spreads evenly, the number of compatible microstates grows and entropy increases. Nothing mystical happens. Multiplicity changes. At the scale of a city, a macro description might be morning rush hour. Many microstates are compatible. Millions of different paths, stops, and delays, all still producing the same macro pattern of congestion. Entropy, in the everyday sense, is high. Many micro configurations match the same macro view. If a strict schedule is enforced and every person takes the exact same route at the exact same minute, multiplicity collapses and the macro description becomes highly constrained. That would be low entropy, but it would also be fragile and expensive. At the scale of language, a sentence like, "We met at the station," leaves many micro details unknown. Which station, which platform, what clothes, what weather, what exact time. The entropy of that statement is high. Many detailed worlds fit the same coarse sentence. A detailed police report reduces entropy by specifying micro details. Again, entropy tracks multiplicity under description, not moral disorder. This is why entropy is powerful. It is the mathematics of how much is being left out and how many possibilities remain when details are hidden. 7. The triangle of readouts: access, update, and coarse grain. Now we see the unity. Probability, energy, and entropy are not three unrelated substances. They are three faces of the same discipline: public bookkeeping under finite access. Probability arises because adjacency can branch and windows cannot always resolve which branch is realized. Energy arises because transformations can be tracked by a conserved ledger across a declared update family and boundaries. Entropy arises because descriptions are coarse, windows are finite, and many microstates can hide behind one macro claim. All three therefore depend on access. Change the window and the readout changes. Change the transformation family and the readout changes. Change the coarse graining and the readout changes. This does not make them subjective in a careless way. It makes them conditional in a lawful way. They become sharp tools instead of vague idols. 8. The discipline gates: what must be declared. Because we are building a science of public claims, Part 30 installs a strict rule. These readouts cannot be invoked without their definitions. When probability is used, we must declare branch set, measure rule, calibration pathway, and predictability limits. When energy is used, we must declare ledger definition, update family, boundary conditions, and what counts as external exchange. When entropy is used, we must declare coarse graining rule, resolution regime, state space, and transformation family. If these are not declared, the claim fails. The claim may still be a poetic intuition, but it is not a certified public statement. This is not bureaucracy. This is the only way to prevent primitive relapse. Otherwise, old myths return. Probability becomes destiny. Energy becomes substance. Entropy becomes demon. The gates keep the language clean. 9. A cosmic analogy. The book of the universe. To bind everything together, we use one final analogy. Imagine the universe as a vast book written in a language of patterns. Each page is a pattern state. Turning a page is a lawful transformation. The order of pages is not imposed by an external clock. It is read from how pages can lawfully follow one another. Now, probability is what we write in the margin when one page has several possible next pages and we cannot know which will be turned. We draw a little tree of possible continuations and assign weights based on our rules and evidence. Energy is the accounting column we keep across the pages. A conserved tally that lets us check that no page turning has secretly created or destroyed structure without accounting. If the tally seems to fail, we learn either that the boundary was not what we thought, or that the ledger was incomplete. Entropy is the measure of how many detailed pages fit the same summary paragraph. When we summarize a chapter, we throw away detail. Many possible exact pages are compatible with the same summary. Entropy counts that hidden multiplicity. In this image, the three readouts are not substances inside the story. They are the tools we use to read the story honestly, given that we cannot see every letter and we cannot track every microscopic ink stroke. 10. What this prepares next. By the end of part 30, we have not removed probability, energy, or entropy. We have made them clean. We can now speak about chance without mysticism, because chance becomes disciplined branching measure. We can now speak about conservation without substance, because conservation becomes ledger stability across lawful updates. We can now speak about disorder and irreversibility without demons, because entropy becomes multiplicity under course description. And because these are now readouts rather than primitives, the next step becomes natural. If even these famous quantities are derived, then the everyday furniture of physics, objects, particles, fields, must also be read as expressed, stabilized pattern forms, not as primitive stuff. That is the handoff. The story moves from how we keep score to what looks like things. 3 more everyday scenes that lock the meaning. First scene, the crowded bus stop. At 5 in the evening, many buses could arrive next. The timetable gives several lawful possibilities, but delays, traffic, and breakdowns create branching. Probability here is not fate. It is our discipline measure over the lawful arrival branches given the window we have. The published schedule, the usual delay statistics, and the live tracking signal. If the live tracking app fails, the window shrinks and the probability distribution spreads. If a road closes, the branch set itself changes. This is the key. Probability is always tied to a declared branch set and a declared access window. Second scene, cooking on a stove. A pot of water is heated until it boils. We often say, energy went into the water. In our discipline, we translate that into leisure talk. The stove plus pot system undergoes updates. Gas burns or electricity flows, the pot warms, the water temperature rises, steam carries heat away. We can keep a tally that stays stable when the boundary is declared. If the kitchen window includes only the water, energy conservation looks violated as steam escapes. If the window includes the room air, the ledger closes again. Nothing mystical happened. The boundary choice changed the accounting. Energy is a conserved tally over a declared update family, not a liquid that disappears when sight is lost. Third scene, a library shelf. We describe a shelf as organized when books are sorted by author and as disorganized when they are mixed. The difference is not moral, the difference is multiplicity. Many mixed arrangements satisfy the coarse label messy, while far fewer arrangements satisfy sorted by author. Entropy here is a count of how many detailed shelf states fit our chosen course label. If we change the course label to sorted by color, the entropy changes because the grouping rule changed. Entropy is multiplicity under coarse graining, not a spooky force pushing books to chaos. 12. Saying it once in clean, speakable formulas. To keep the language sharp, we can say the three readouts in plain text formulas. Probability equals a measure over lawful branches. Probability of branch B given state S and window W equals mu of B within the branch set adjacent to S under W, where mu is the declared assignment rule. Energy equals a ledger sum that stays constant across a declared update family. Energy of state S equals L of S, where L is the declared tally. And conservation means L of S before equals L of S after, for every lawful update in the family, within the declared boundary. Entropy equals a summary of multiplicity under coarse description. Entropy of macro description M equals log of n, where n is the number of microstates compatible with M inside the declared window and constraints, and log can be any agreed scale that turns huge counts into readable numbers. These are not metaphysics. They are reminders that each word must come with a definition. 13. The refusal tests that keep the science honest. Because these words are so famous, they are also the easiest places for smuggling. So we install refusal habits. We refuse a probability claim if the branch set is not named, if the assignment rule is unstated, if calibration is absent, or if the claim pretends that probability is a property of the world independent of window. We refuse an energy claim if the ledger is undefined, if the update family is vague, if boundaries are hidden, or if energy flow language is used to cover missing accounting of losses, exchanges, or coarse graining. We refuse an entropy claim if the coarse graining is undeclared, if disorder rhetoric replaces counting, if state space and constraints are hidden, or if entropy is treated as an agent that causes events rather than a readout that summarizes multiplicity. With these refusals, the three words stop being worship and become instruments. Why the demotion is actually a deep unification. Once these readouts are treated as derived, a quiet unity appears. Probability tracks branching. Energy tracks ledger stable change. Entropy tracks hidden multiplicity under coarse view. In all three cases, the same moral holds. Declare the window. Declare the lawful transformations. Declare the bookkeeping rule. Then the readout becomes public. This is why part 30 belongs exactly here, after dynamics, adjacency, conservation, provenance, and stochasticity. We have earned the right to reinterpret the famous words without breaking them. Now the door opens to the next layer. If the bookkeeping quantities are derived, then what looks like stuff, objects, particles, fields, must be read as a stabilized, expressed forms of Phi pattern, supported by the same gates, the same boundaries, and the same refusal discipline. In that next layer, we will watch how stable things are certificates of persistence, not primitive blocks of matter. Always, peace be upon you.